Thank you very much for coming back to this channel and for watching this video. I want to teach you how to derive those multiple angle identities. So we derived sine 2x and cos 2x using complex numbers in our previous videos. And if you haven't seen that video, check it out. Today we want to derive sine 3x, sine 4x, and so on using complex numbers. So let's begin with the De Moivre's theorem. This is the De Moivre's theorem for raising a complex number to a power n. Now, in this case, if we take n to be 3, that means we want to derive the triple angle identity for sine and cosine. So, for n equal to 3, you have cos x plus r sine x all raised to the power of 3, and this will be cos 3x plus r sine 3x. After we've done this, you can choose n to be 4, 5, 6, and you follow the exact same procedure. After we've done this, we can simplify this side by using either the Pascal triangle, or we multiply this expression by 3 times. Trace. Alright, so we use the Pascal triangle. We have cos x all cubed plus cos x times r sine x, but this cos x is squared, and then you have a TD right here. So it's 1, 3, 3, 1. For those of you who do not understand what we are doing, 1, 3, 3, 1. So that's what I'm using. The coefficient is 1, the coefficient is 3. So, and then you have another 3. So that's 3 times cos x raised to the power of 1, and then r sine x all squared plus 1. The last expression will be r sine x all cubed, and this will be equal to cos 3x plus r sine 3x. We can proceed by simplifying. So this is cos cube x plus, now this is 3r cos square x sine x, 3r cos square x sine x. Now this r square is -1. So -1 times the entire expression here will give you -3 cos x sine x. And then r cube is r squared times r. So r cube is r squared times r. But you know r squared is -1. So this will be -1 times r is -r. R cube is -r. So this will be minus r sine cube x. And everything is equal to cos 3x plus r sine 3x. So the real parts are those parts that do not have an r, and imaginary parts are those parts that have an r. So what are the expressions here that don't have an r? So you have cos cube x, it doesn't have an r, and then you have minus TD cos x sine x. It doesn't also have an r, but this sign is square, so it's sine square x here. It doesn't also have an r. And then you move to the term that have an r, you have 3r cos square x sine x minus r sine cube x. And everything should give you cos 3x plus r sine 3x. You can factor out an r from here. So I'll put this in parentheses as cos cube x minus 3 cos x sine square x plus, it will be 3 cos square x sine x minus sine cube x all onto r, and this is cos 3x plus r sine 3x. For two complex numbers to be equal, their real parts must be equal, and their imaginary part must also be equal. So what is the real part on the left hand side? That's cos cube x minus 3 cos x sine square x. It should be equal to, the real part on the side is cos 3x. Also, the imaginary part on this side is 3 cos square x sine x minus sine cube x. This should give you sine 3 identity is this. We want the identity for cos 3x to be only in terms of cos, and we want the identity for sine 3x to be only in terms of sine. We know sine square x is 1 minus cos square x. So we have cos cube x minus 3 cos x times 1 minus cos square x. Everything is equal to cos 3x. Because we want the entire expression to be in terms of sine, so we replace the value for cos square x. 1 minus sine square x multiplied by sine x minus sine cube x is equals to sine 3x. Cos cube x. So negative 3 cos x times 1 is negative 3 cos x. And then negative 3 cos x times negative cos square x is positive 3 cos cube x. And everything is equal to cos 3x. If you simplify this side, you have 4 cos cube x minus 3 cos x is equal to cos 3x. This is the triple angle identity for cosine. 3 sine x times 1 is 3 sine x. And then 3 sine x times minus sine square x is minus 3 sine cube x. Minus sine cube x is equal to sine 3x. And this will just remain as 3 sine x, minus 3 sine cube x minus sine cube x is minus 4 sine cube x. And this will be equal to sine 3x. We hope you like this video. Give it a thumbs up. And do not forget to share this video with your friends, family members, relatives, brothers and sisters, and even including all those people who feel that they do not want to know math. Share it with them so that they can actually try to understand the basics of learning this kind of stuff.